Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. Today we are in Atlanta, Georgia, recording live from Supercomputing 24. SC24 is a conference that historically was really focused on supercomputing and the high-performance computing market, but it's really expanded with the advent of all the interest in AI and GPU computing, which really wraps up into this show as well. So very big conference and a lot of exciting technologies that we're talking about here. If you're new to the podcast, Data Unchained is all about how do we take advantage of data sets that have become increasingly decentralized. No more are we really dealing with mainframes that the applications and people are all in the same building with the data. It's now being created in multiple locations. Often a cloud is involved. Sensor data being generated from space can all be kind of thrown into the mix. And so Data Unchained digs into both the challenges of decentralized data as well as the opportunities if you can really tackle it with some great solutions that our guests talk about. So without further ado, I would like to introduce Jon Toor. He is the CMO of Cloudian. Welcome,
Molly.
Jon.
Thank you. Good to see you.
Great to see you. We've known each other, I feel like, for a long time, working in the same industry. So it's great to actually have a chance to talk on this show.
Wonderful.
Tell us a little bit about yourself, maybe without going into Cloudian just yet. Tell us a little bit about your background.
Okay, so my background is basically a long career in enterprise storage. I go back through a number of startups and a couple of large companies as well, including Brocade, Seagate, Maxtor, some of the more enterprise-ish players. And for the last few years, few startups on the storage and also the storage networking side. So kind of seen a variety of different things.
And Cloudian is an object storage company. I mean, simply put, tell us a little bit about Cloudian.
Yeah, so Cloudian has been an object storage company founded in 2010. We primarily do S3 compatible object storage and have since our very beginning, which was kind of a prescient move on our part of our founders in that S3 back then was just one of the many object storage protocols. Since then, object storage has really become the dominant storage type on Earth by virtue of the growth of the AWS infrastructure. So the S3 protocol has become something of an industry standard, and it's what we've based our solution on since the beginning. So S3 compatible object storage, but in your data center. So you can take the same data that you would run in Amazon, and you can run it on-prem. Matter of fact, we're an Amazon partner as part of their hybrid cloud initiative because of our S3 compatibility and the fact that we can manage data across both environments, on-prem and in the cloud. So really, we think of ourselves as being an on-prem cloud provider that's in your data center, but managed very much the same way. The same level of simplicity, the same level of scale, the same S3 API, same level of security. It's just that it's all behind your own firewall, under your control, and in your data centers.
Object storage, in thinking about what it was originally built around, I think a lot of us think about it as well-protected, highly durable, relatively inexpensive storage for kind of longer-term storage. Would you agree with that? That's the general premise of how people originally thought about it.
That's how it's been seen that way. That's how it's been used for much of its lifespan. And the interesting thing about that is the same thing was actually true of file. File started out the same way. It was a technology used as your printer queue.
Sure.
It used to be called a print and file. Matter of fact, it wasn't even called a file server. It was called your print and file server. And that evolved into being an enterprise product. And I remember that NetApp was so proud when they announced that Southwest Airlines was running their reservation system on NetApp, because that was a huge step forward that was being used as primary storage. We're seeing that same evolution right now with object storage, and I think it's largely because of exactly where we are today. What we're seeing in this show we're at is the evolution of the use case. Storage is always driven by the use case. The evolution of the use case is now requiring that really all data be immediately accessible and usable as part of a training model. Because as you'll hear at this event over and over and over again, the more the data, the better the model. Mm-hmm. So the more data you have to train on, the better the output's going to be. And that's really what it's all about, is creating models which are more realistic, more predictive in their ability to analyze what you need to know for the future. the way you do that is by looking at the past. And the past, of course, is all that data that you have.
Absolutely. And so when you're thinking about gaining access to a lot of data, being able to access an object store, which has probably a lot of data in it, is a great step. And then working together, between our two companies there's other data sets too, and kind of aggregating that, making it easy for our joint customers to be able to get access to all their data for a single model is kind of an interesting concept. Instead of, your siloed data, working together to create data sets that may be coming from remote sites, maybe are in different types of protocols, maybe are, difficult to access otherwise, is something we work well together, I would say, on. And so getting access to a lot of data across the protocol that the application or the tool wants is interesting. But I think really the point you make, though, about the dominance of data that's ended out in S3 protocols is something not to be, trivialized, that customers need all their data and they need to find tools that can get it to their GPUs and use it in a really fast way. And that's not what enterprise systems typically did. Enterprise systems kind of stored. Would you agree with that?
Absolutely. The way storage has traditionally been run is by application, right? So you have your application set for your CRM, you have your data set for your database you're running finance off of. When I was running marketing at Brocade, my marketing data was stored across 5 different storage silos for marketing alone. Say nothing of finance, manufacturing, engineering, et cetera. Just marketing was 5 silos. And I think that was very traditionally the way it was done because storage was tied to an app. Well, the challenge with that, of course, is that now all that storage is not accessible for training in a way that makes it usable.
Right.
Data is not usable unless you present it to the application in a way that it can understand and easily access. So I think what we mutually do is take this disparate storage environments and we present it to the customer in a way that it can be used easily by training models, thereby making all of that underlying data more valuable, which is, of course, is the end result that everyone wants. I mean, I want to derive the greatest possible value from my data, making it accessible via the Hammerspace layer, and the Cloudian layer does exactly that.
It's interesting. One of the things that we talk about internally at Hammerspace a fair bit is the relationship of users to data has really changed. It used to be one-to-one, an application owned its data or a user owned its data. And now there's a many-to-one relationship. You have many data scientists or engineers, maybe many models, all trying to work with the same data set. And that's created some really different architectural requirements that you want to have shared storage and shared metadata, so there's a good understanding outside the person or application that created the data of what's inside there. Do you guys bump into that very much? The idea that the person or the application that created the data isn't always the one who's accessing it in these kinds of AI environments?
Absolutely, and of course that cuts both ways, and which is we want to make sure that it is accessible to the people that need it, but you also have to make sure that it's kept protected from people that you don't want to have it accessible to, and that's a big part of our story. So if you look at what we think of as why Cloudian or for AI, well, we think of it in terms of the S3 compatibility, the scalability of the solution, and then the third one is the security. So 3 S's. And that security one is very big for the reason you just stated, right? You have to make the data accessible to a wide range of users, but you have to make sure it's protected from rogue operators that you don't want to have people using it or accessing it or treating it badly. And that's part of the beauty of object storage, is that it is the storage infrastructure that was designed for the cloud. It was designed fundamentally to be accessed on the web. And that means that it's open to everybody. It's not sitting, it wasn't designed to be sitting, of course, in our case, it usually is behind a firewall, but security is kind of built into everything we do to make sure that, what you say is possible.
Yeah. So I think that while we're kind of thinking about the implementation of this, you guys announced this week using GPU direct to an object store, and that's an industry first, and I think that's cool. One of the things I love to see the technologists, because this industry is evolving so quickly, is putting information, benchmarks, and data out there to help a customer who's designing their GPU computing architecture help them understand how fast should this go. And if I'm training versus iterating and all the different types of workflows, which technology will work. So I love, one, just that both of our companies are putting a lot of benchmarks and information out there. But maybe just talk a little bit about GPU Direct for Object. Why does that matter? Which part of the AI workflow? Maybe tell us a little bit about that, because you're the first ones doing it.
Yeah, so GPU Direct, as you already know, because GPU Direct as a technology has been around for a while, 4 years, and in the file environment, it provides remote direct memory access right from the storage into the GPU. So it bypasses the CPU as part of the food chain, and that means you can dramatically increase the bandwidth because you can do things in parallel across many, many paths all at once without having to go through the CPU. We are doing the same thing now with Object.
Okay.
So Cloudian is, by definition, a clustered storage environment. It could have hundreds of nodes. And the way you achieve performance is by streaming from all those nodes in parallel, right? You can do parallel operations from as many nodes as you want, as long as the other end of the pipe is able to accommodate that.
Sure.
And that's exactly what GPU Direct does, is it gives you that direct path into the GPU via, today it's 400 gig networking links, and that can, right now we've demonstrated already 200 gig from a fairly modest Cloudian platform, and we know we can scale to terabytes simply by increasing the size of that test infrastructure, which is exactly what we're doing right now to prove that out. But what this does for customers is it says now all that data that you've had in this kind of archive-ish environment where it really wasn't readily accessible can now be accessed in one single namespace at whatever speed you need to accommodate your training environment. So however many GPUs, and if you're like Elon Musk out deploying 10,000 GPUs, you can scale this environment at a rate which is going to allow you to feed that environment. And that's what's really exciting about this, is you've now joined together this huge pool of data, this data lake, and made it accessible at very high speed into this most voracious of data consumers, the GPU training environment. And that was not possible before this announcement.
Yeah, absolutely. And so when an organization is thinking about their AI infrastructure, they have now the flexibility to use their GPU cluster or clusters, all the data, no matter if it's file data or object data, at really efficient, high-performance speeds, and can unify all that data into one namespace to make it really easy to know what data you have, assign who should actually be allowed to use it, and what are they allowed to do with it. So unifying the data set and then providing it at super high speeds to the native protocol or native application that one was originally designed to use it is just a great move forward in how these workflows work.
Yeah, this is all about simplification, because accessing a small amount of data is easy, right? You can do that with a flash stick. But accessing and really making use of a large amount of data gets exponentially more challenging as that data set grows.
Right.
And that's what object storage is unique for, is the fact that it uses a flat namespace. A flat namespace is just it's a technical way of saying it's essentially unlimited within a single environment. So the flat namespace in itself gives you the ability to consolidate. And of course, in storage world, consolidation is a great word because it means simplification, and simplification ultimately means more reliability, less management overhead, and frankly, greater value for all the data because you can access everything and put it to work. So the fact that you've simplified your environment and you've made it readily accessible, the thing that's really driving this right now is what our customers are saying is, we're seeing the training data sets grow exponentially. And the next wave that's really going to push that is going to be multimodal, right? When people start integrating video and imagery information into their training data sets, which is already happening.
For sure.
And then synthetic data. And when you talking about synthetic data and your ability to manufacture training information simply by using a computer model, at that point, your training data is unlimited in size.
Absolutely.
And that means you can do better. You can do better models. You can make more accurate predictions. When I can train my autonomous driving car under every scenario of driving I can think of, that's going to make my autonomous car much more useful as a vehicle that's truly autonomous.
Absolutely.
But to do that, I'm going to need a lot more data than I'm just getting out of the cameras from the cars on the road. I'm going to need to generate data for every scenario you can think of, and that synthetic data is going to push up the size of those training data sets.
Yep.
So we see this as being the front end of a wave. If you look at the growth in training data set size is just going from GPT-3 to GPT-4, that already is phenomenal. It's many orders of magnitude. From GTP4 to 5, that same thing again, and it's just going to go beyond that as you start moving into this new realm of training models on synthetic data, all the enterprise data, multimodal data. The sky's the limit.
Absolutely. It is exciting times for sure, and a lot of change happening at a pace I don't think I've ever seen in my career anyway. It's exciting, though, that to see some of the threads that we're all following are coming together. The simplicity, the consolidation, not having to have specialized bespoke infrastructure all over your environment, which is difficult to manage, creates a lot of manual processes. Like a lot of us are focusing on how do we streamline this, automate it, and that's really helping our customers a lot. We were talking to Gary Grider from Los Alamos just before you, and he was talking about how important that is to his national lab, that he can't have a bunch more bespoke things and do all the computing work that's expected of him. So it's great to see industry bring these technologies together and make it easier for our customers as well.
Yeah, no, storage lasts a long time. It's 5 years, and you're going to have different layers of technology in your data center. You've got to be able to bring them all together. Consolidation at that level is a continuous challenge. Also, consolidation at our level is also a challenge because of the trends we just talked about, right? The size of the data sets. You cannot have those distributed across multiple environments. So when you start talking about tens of billions of objects or trillions of parameters, I mean, these are numbers that go beyond anything you find in the enterprise today in a single namespace. But at the same time, they're going to have all the other stuff to work with. They need to have a consolidation layer to help make sense of all that. And obviously, that's how we really work together.
Absolutely. Hey, Jon, thank you for taking time. It's a busy week for everyone, so taking a minute to have a conversation like this is much appreciated. Thanks for coming by the booth.
Thank you, Molly.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.